Hello engineers, welcome back to our new series of learning Revit API development by using parallel programming strategy. In this strategy, we are using Dynamo scripting and C# program. Today, we are looking at a script that imports and exports room metadata. In our previous video, we developed a Dynamo script that imports and exports room metadata. If you want to understand this video better, I suggest you to go and watch the Dynamo, the part 1 video first and continue with this. You will find that video in the I icon as well as I am providing the link in the description as well. So let's break down the script. In the top, we are adding libraries, importing namespaces, thinking of like bringing toolboxes into your workshop. The Revit API toolbox let us talk to Revit models. The closed XML is our Excel toolbox. The system.links are general purpose toolboxes for a collection and query. Here we are declaring the transaction into manual, the metadata telling the Revit I will manage the transaction myself. By implementing external command here, we are saying Revit, you can call me when the user runs this add-in. This is how it will works. The execute method is doorway. When you click the add-in button, Revit calls this method. Inside we grab all the action documents and classes implementation and method implementation. For a better understanding, we are implementing a form here. When user runs the code, that will appear a form like this. This has two buttons, simple import and export. This will define in which way we should work, either the import action or the export action. Once we define our selection, that selection will give the results here. If the action the user selected import, we read Excel, each row become a room data object like a card with details about a room. This is encapsulation. Instead of juggling, losing strings and numbers, we are wrapping them neatly into a class. We now search the room model for a room with the same number. We collect all rooms, filter by category and compare the room number parameter. This links in action, a powerful way to query the collection. When we find a room, we open a transaction here. Think of transaction like a safe box. You open it, make changes and then lock it again. Inside we set parameters like all the occupancy and comments, department and base finish and wall finish and floor finish. Then we commit and close it. If we do not get the room with the same number, this will give a error message like room element not found. If the room found, this all parameters will update and we will get the output import task completed. If the user chose export, we flip the process. We collect all rooms first, read their parameters and store them in room data object. This ensures the same schema works both the ways. Excel rows and Revit parameters always match. First we create header like a room number and occupancy. Then we loop through the list, writing each room data into rows. This is serialization, turning in-memory object into file format we share. At the bottom we see room data class. This is a blueprint. It defines properties like all the room number, name, area, finishes, all the parameters that we are looking for. This class is the bridge between the Revit and Excel. On import, Excel rows become room data. On the export, Revit parameters become room data. In reading room data from Excel, we open the workbook first, skip the header row, the first row, and map each cell property, each Revit cell property. This is parsing, turning a row spreadsheet into a structured object. Then we add that data into rooms and it will return the room data. And now in write room data to Excel, we create a new book, add headers and loop through the list to fill the rows. From the second row, we'll loop through the rows and fill this complete data into the Excel. Finally, we save this file into the path. This is persistence, making sure our data lives beyond the program execution. The best practice which we followed herein, the transaction, we are updating in one transaction we are updating batch, we are doing batch update in one transaction for the better performance. Room lookup, this is a powerful link. From there we filter directly with the help of room number and we get that room object into here and we'll update the data. This will be very useful when we are syncing in BIM coordination, room schedule to design changes. In a facility management, updating occupancy and department info from the external systems. In QA/QC, export data for audit, then import corrections. Let's run the code. Check the room data. So this is metadata we are looking for. This is empty. Let's import the data. Add-ins, run, and this is our UI. And import action, import task complete. Let's check. All this data was added here based on the room number. All this data were added. Let's export the data. Export completed. Let's check this as well. So successfully exported into the spreadsheet. That's it for the day. If you are a BIM enthusiast and wanted to learn Revit API development, I recommend you to follow the channel and subscribe. And if you have any questions, let me know on the comments. I'm happy to address. Thank you for watching. Don't forget to like, share, subscribe Smart BIM Studios.